just trying to see if a switch works or maybe see how much resistance it has. But using an ohm meter has some significant problems. The number one problem of using an ohm meter is that it passes milliamps through whatever you're testing. Milliamps is thousandths of an amp. It's not that much. And the problem is, I was using these two examples last night. See, if I've got a 20-foot in diameter pipe and it's 98% clogged, if I test it with a garden hose, I'm not going to find any clog. Because what I'm trying to flow through, what do big boys do when they're not using their pens and pencils? Come on now. Who wants to be a big boy when they grow up? Okay, then what we do is we put our pens and pencils down unless we're going to use them, huh? Because that way we don't spend our time making distracting noises. Huh. I'm just spitballing here. My point was, see, if he's just using a garden hose to check for clogs, he's not going to find that big-ass clog. Because the garden hose is not going to flow enough to cause a backup with a clog that big. But if everyone flushed their toilet at the same time, you'd sure find the clog. See, that's the problem with ohm meter testing. The ohm meter testing, it's not going to flow a whole lot of current. And since it doesn't flow a lot of current, like for instance, let's say I stripped that wire on the bottom, but I wasn't careful when I stripped it, so I ended up cutting up a whole bunch of strands. Okay, so now I've only got one strand of wire. Well, if I test that strand of wire with an ohm meter, it's going to pass. Because if I'm just trying to pass milliamps, one strand of wire will be plenty. Problem is, when I try to pass 20 or 30 amps, that one wire ain't going to cut it. It's going to get really, really hot, and it's going to have super high resistance, and it's going to cause a failure in the circuit. So as a result, ohm meter testing has significant limitations. Okay, so that's a passive test. The circuit is de-energized. I'm just going to come in here with an ohm meter and do my testing. Same with switches. All kinds of, in fact, we found a relay today that was bad on the switch end. Active testing, on the other hand, I'm going to apply voltage to them. Now, where am I going to get the voltage? Well, the best, most effective and efficient place to get voltage is through this beautiful thing right here called the power probe. Now, they do make Chinese copies of these. I don't know how good they are. It's not like this is an extraordinarily complicated device, but I'll tell you that when it comes to test equipment, I'm kind of partial to quality. Why? Because if your test equipment isn't working correctly, it's going to make you think something's bad that isn't, and it's going to make you think something that isn't bad is good. So I'm kind of partial to that power probe. They invented this thing. Everything else is a copy. These are like $100, $120, whatever. Oh, is that a lot of money? Maybe you should get an FJOB. Maybe you should get an FJOB. Maybe you should consider what you do on Monday. Loborato sale caro. Yeah. Yeah, their God is their belly. We read that last night. Yeah. I mean, you can go ahead and try to make your life as comfortable as possible. Oh, I'm not going to wake up at 3 o'clock in the morning. Okay, well, Andrea will. Maybe you can rent a room from her someday. You make a shrine to your laziness and you sacrifice your life on the altar of your laziness. And you think that's winning? Yeah, like that. I know, right?
These are LEDs?
Yeah. Light emitting diodes. Yep. Crazy bright, huh?
Yeah,
Plus you can go like this for the longest and it's not really going to get hot. That's the thing.
LED?
See, you can put your fingers right there. It's not even warm.
That's fine.
Yeah. So LEDs is an efficient way of making light because it spends its energy making light instead of heat. So that is what I do about that, but you have to have a convenient 12-volt power source. So That's the impediment for most people, but that's why I like the power probe. Hey! Yeah, I'll give you a... Well, if I'm working on cars, I need to have some kind of 12-volt power supply. Yeah, that's good. If you want to do active testing on a 120-volt load, now all of a sudden you got to have 120 volts available. That's potentially dangerous. Now look, the ohm meter, you're not going to hurt yourself. As long as you don't apply it to an energized circuit, the ohm meter is not going to hurt anything. However, you get 120 volts, now it's potentially deadly. Yeah, potentially. Oh, it only gets worse from there. What? I'm sorry. That's the game. That's the game. See, for a whole bunch of people that claim to be Del Rancho, you have to understand. Del Rancho, you would have learned a long time ago. You know, you would know by the time you were 8 that cows are dangerous, bulls are dangerous, horses are dangerous, geese are dangerous. You know, goats are dangerous. See, you would have learned that dogs are dangerous. You would have learned a long time ago that this world is filled with dangers and it requires us to be sober-minded and alert. But since you have grown up in the cocoon of Montclair, where you are insulated from adversities of all sorts, you think you can just walk through life like a blind dog in a meat factory. Nah, life ain't like that. That's one of the reasons when students come in here, or when they go freaking Briscoe's class. You know, wood shop, you got all these freaking band saws, all these freaking chop saws, a million different kinds of saws and planers and all kinds of crap like that. You could cut your hand off super quick. Okay. That's why you're supposed to start off slow. 6th grade, 7th grade, 8th grade. So by the time you get 9th grade here, you've got an idea about how to stay careful. You know, how to protect yourself. Well, see, the thing is, if you grew up in East LA, you would learn not to provoke hostile people, right? Because there's a bunch of hostile people. You would learn not to provoke them. So you wouldn't be bragging about your fancy clothes. You wouldn't be busting out your fancy chains. You would not be busting out your fancy shoes. You would not be doing none of the stuff that kids do around here, because after all, this is Candyland compared to East Los or Rialto. Yeah, this is Candyland. So as a result, the kids don't learn to be careful about the way they act, the way they talk, the things they wear, the things they do. And it bleeds over into their studies, you know. I mean, my auto classes are more dangerous than every other class on campus combined. Okay. How come nobody ever gets hurt? Because I clamp down on them hard and I make sure that you're well prepared by the time you get out there. Now, if you had 6th grade shop, 7th grade shop, 8th grade shop, like I did before I got into auto, 9th grade shop, 10th grade shop, I had 6 years of full-time of shop before I got into auto, and, you know, I had a workshop in my garage. So I had already hurt myself very deeply by the time I got to school life. That would be different. But until then, you gotta make sure you got your head straight. And that's how students don't get hurt. I mean, we're out there freaking welding for 5 hours, at least 5 hours a week. How come nobody ever gets hurt? Because I tell the welders, look, somebody gets hurt, this thing is done. We ain't doing this anymore. So as a result, they kind of police each other. They police themselves. And if somebody looks like they just want to be a screw up or a freaking idiot, they get pushed out, you know. But it has to be that way, because I'm going to be over here while you guys are over here, and you can't be unsafe just because I'm not standing next to you, because I can't be standing next to you. Anyways, the point I was trying to make was applying voltage. Now, it's easy when you're applying 12 volts, you know. When you're applying 12 volts, okay, so I touch 12 volts, B plus and B minus at the same time. Nothing's gonna happen. That's not a problem. Unless my skin is wet. Unless someone poured a bucket of water on me or standing in the rain, I guess. But 120 volts, yeah, you don't want to be standing in the rain. You don't want to be sweating. In fact, you don't even want to touch 120 volts.
Yeah.
As a result, well, I'll give you a perfect example. You know this cul-de-sac over here, right over whatever the street this is that goes this way by the baseball? Yeah.
Mm-hmm.
The cul-de-sacs over here, you realize that most of those houses were built by Montclair High School students. Yeah. Can you imagine getting a Montclair High School student up on a roof today?
Mm.
Yeah, for sure. Or using a nail gun? Or wiring up a house? See, this is how far education has fallen in the last 50 years. Because that was in the 70s, so that was what, 50 years ago? Yeah, 50 years ago, students in this school, students your age, were building houses. Now what? Now you can't even do it in freaking Minecraft. What the hell? Yeah, it's too much. Yeah, exactly, too much work. Yeah. Fact. Okay, so what is load testing? Well, the thing is, I can apply voltage to, you know, well, for instance, this is a perfect example. Dum 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 dum. This thing right there, that's a fuel pump, yeah?
Yeah.
Runs on 12 volts. Okay.
What is this?
So
It's a switch.
I can go ahead.
Yeah.
I can go ahead and run an ohm meter to it. And I find out it's got, 15 ohms resistance, whatever. So I know the coil's good because it's a motor, right? So it's got a coil.
Yeah.
And I can go like this and hook up B minus to one side, B plus the other side. Now, I know the motor turns. I don't know if the pump works because, after all, there's two things that the pump needs in order to be able to say it's a good pump. Pressure and flow, right? Well, I don't know if it'll do pressure and flow. I know the freaking motor will turn. But that don't tell me nothing. Maybe the shaft's broken that goes to the pump. So in order to load test it, I would have to put fuel inlet here, fuel outlet here, and I would have to measure the outlet pressure and flow. That takes, can you see how it takes much more sophisticated test equipment? As I go down this way, it takes more sophisticated test equipment, but it's also going to give me more accurate results. I mean, I can look at the pump and say, well, it looks like it should work. Well, that doesn't tell me nothing. Okay, now I test it with an ohm meter. Okay, well, I know the coil's good, so it should work if I apply voltage to it. Doesn't mean it will.
Work. Blue.
Because the coil could be good, but the shaft could be frozen. Okay, so now I apply voltage to it and the thing turns. Okay, well, I know the motor turns. I know the motor works. Doesn't tell me if the pump works. Now I hook it up to a fuel inlet and a fuel outlet. Now I hit voltage to it and fuel comes out. Okay, so that tells me the inlet side works. Now I got to check the outlet side to see if I'm getting the flow and the pressure that I need within specifications. Okay. That's probably going to take some specialized test equipment. Like when I go to Connie and Dick's, Scott's got a whole bench where you can take out all your injectors and put them all in a row, and you got clips that go to each of them, and then he fires them all at the same time, and you can look at all the injectors firing at the same time, and they should all look the same, right? Yeah, last vehicle I took them down to test them, one was stuck open, and the two of them were like clogged, almost completely dry. But that's an expensive, sophisticated piece of test equipment that hardly anybody has. That's why I had to go down to the shop. So see, what we're doing is we're going from real generalized low budget testing methods to the hardcore stuff. Because after all, if I want to test the fuel pump inside the tank, inside the vehicle, I might have to drop the fuel tank. I might have to take the bed off the back of the truck. That could be a lot of freaking work. I would rather test all this stuff the easy way first, see if I can get it to fail the easy tests, so that I don't have to do the difficult tests that are more time consuming and take longer to set up. See, that's the thing. Because if I have it set up to load test it, I mean, okay, it's a perfect example, the starter motor. Okay, well, let's see what I know for sure. Let's see. Oh, this one. That'll work. This one? Okay. I know the solenoid will shove out. And I know the shaft will turn. But do I know the shaft will turn if it's connected to a freaking crankshaft ring gear? No. That requires a load test. And unfortunately, at least in the realm of starters, now if you work at a starter rebuilding place, they're going to do a current draw test. But I don't have the equipment to load test it. The only way I can load test it is by putting it in the vehicle and seeing if it can turn the engine. That's why I want to do all the other testing first. Like I want to make sure, for instance, that the battery's fully charged. I want to make sure that the connectors are in good shape. I want to make sure that the cable's in good shape and that the bolts aren't loose or a bunch of other things aren't going on. That's the thing.